Good morning, dear children. Today we will start with power of lens. Okay, we will discuss about the power of lens today. So, before we come to that to this topic, power of lens, you should know about the focus and the focal point. Okay, so I already discussed that a long time back in the previous class. Okay, now let us consider a convex lens and a concave lens. So what happens in a concave and a convex lens? So convex lens is known as the converging lens. Concave lens is known as the diverging lens because the rays of light they get diverse in concave lens, and in convex lens the rays of light they converge, they meet. So let us consider first as a convex lens and a beam of light parallel to the principal axis. When a beam of light parallel to the principal axis, when it falls on the convex lens, after refraction, they converge at a point. And that point in which the refracted ray they meet, that point we call it as a focus or the focal point. Okay? And similarly, in case of a concave lens, a beam of light parallel to the principal axis, when it falls on it, the refracted ray they diverge, and it seems that the rays of light are coming from a point F, that is from the focal point or the focus. And the distance between the focus and the optical center, the distance between the focal point and the optical center, we call it as a focal length. Okay, so please refer this diagram, please follow the diagram here. These are the beam of light which are parallel to the principal axis. When it falls on the convex lens, the refracted ray, all the refracted ray, they converge, they meet at a point F, and this F is the focal point. And the distance from the optical center and the focal point is known as the focal length. Likewise, in a concave lens also, a beam of light parallel to the principal axis, when it falls on the concave lens, they get diverged, and it seems that it appears that the rays of light are coming from the point F. So this F is the focal point in case of a concave lens, and the distance between the optical center and the focal point known as the focal length. Now these are the conditions taking place in case of a concave and convex lens. So in a convex lens the rays of light they converge, and in concave lens the rays of light or the beam of light they diverge. So this convergence and divergence of refracted ray which are taking place in a concave and convex lens gives the power of lens. So the power of lens is the degree of convergence and divergence of the beam or the ray of light when it falls on the lens. That is, when you fall on the lens means that is on the concave lens as well as in the convex lens. So therefore, it is the degree of convergence and divergence. So when we consider convex lens, now let us consider only the convex lens. Okay. So in a convex lens, when a beam of light or when the rays of light or the beam of light, when they strongly focus very closer to the optical center. That means the rays of light when they converge, then this converging point is very closer to the optical center. So in that case, the power of lens is said to be has more power. That means the lens is having more power. Okay, so how it happens that when the rays of light or the beam of light, when they focus strongly closer to the optical center, very close to the optical center, then the lens is said to be as the power of the lens is said to be as is having more power. The lens will have more power. Likewise, when they focus far away from the optical center, then the power is having less. Okay, so the power is more. The power of the lens can be more, or the power of the lens can be less, depending upon the convergence of the refracted ray in the closer to the optical center or away from the optical center. Okay, so therefore, when this lens or when the beam of light falls on the focus, or when they falls closer to the optical center, okay, and that distance we call it as a focal length. So therefore, power of lens is related with the focal length. Okay, so the power of lens can be more, the power of lens can be less. So depending upon the focusing of refracted ray, which are either closer to the optical center or which are farther away from the optical center. So since this refracted ray are focusing at between this one optical center and the focus, okay, so that distance we call it as a focal length. So therefore the power of lens is related with the focal length. So therefore let us come to the definition of power. Okay, so power of a lens is the reciprocal of a focal length. Power of a lens is the reciprocal of focal length. Power equals to 1 by f. So whereas P is the power, f is the focal length, and this focal length is always expressed in meters, not in centimeters. Either values given in centimeter also you have to convert into meter. Always this is expressed in meters. So focal length is expressed in meter. Okay. So therefore power of lens, the definition, power of lens is the reciprocal of a focal length. So from this definition, so reciprocal of focal length means what happens is that now this power is inversely proportional to the focal length. Reciprocal means power is inversely proportional to the focal length. That means if the focal length is more, power will be less. If the focal length will be less, power will be more. So how it happens? So when the focal length is less, that means how the focal length can be less is that when the refracted rays, when they are focused or when they converge very close to the optical center, then the focal length, the distance between the focal length will become less. Okay, suppose for example at this point, that means closer to the focal length, the refracted ray will focus closer to the focal length here. Okay, that is optical center. Then this point, let us consider OF. Now this OF means the focal length. Now the focal length is becoming very less. So when the focal length is less, the power will be more. Okay. Then when they focus farther away from the optical center, that means away from the optical center, the distance of focal length will become more. So if the distance of the focal length will become more, then the power will become less. So these are the conditions. Okay. So therefore, we follow the convex lens. We are following the convex lens because in convex lens actually the rays of light they get converged. Okay, and they can be converged farther away from the optical center, or they can converge very close to the optical center. When they converge very close to the optical center, okay, then the focal length will become less. So when the focal length will become less, power will become more. Okay. Similarly, when the refracted ray will be focused away from the optical center, then the distance of the focal length will be more. So if the distance will be more, power will be less, since the power is inversely proportional to the focal length. So therefore, power is defined as the reciprocal of a focal length. Okay, so these are the things. Now the next point is here, the unit of power. The power is always expressed. The SI unit of power is diopter. D-I-O-P-T-R-E, diopter. Okay? The SI unit of power is diopter, and it is written symbolically. It is written capital letter D, not small letter d. Capital letter D denotes the power. Okay, power. That means the power of length. The SI unit of power is diopter. And we can express this diopter in a symbol writing capital letter D. Okay, so these are the points. Now let us come to the definition of diopter. Now what is diopter? One diopter. So one diopter is the power of length whose focal length is 1 meter. Okay, one diopter is the power of length whose focal length is 1 meter. That is known as the diopter. So diopter is the power of length having a focal length 1 meter. So remember the definition of a diopter. And diopter is the SI unit of power. Okay, and it is measured. Okay, and this power is measured by instrument. It is measured by instrument known as dioptometer. Remember this one also. It is an instrument. This power is measured by instrument. Okay, and that the name of the instrument is known as the dioptometer, and it is used by the optician. Okay, to measure the power of spectacle lens. It is used by the optician to measure the power of the spectacle lens. Okay, so in spectacles also the power can be negative and positive. Okay, depending upon the defect of eye. Okay, and therefore when we consider and when the power can be negative and positive, the convex lens, let us consider convex lens. In convex lens, the focal length is taken positive. Focal length is taken positive. So if the focal length is taken positive, therefore the power in a convex lens is considered as positive. Okay, so in convex lens for positive, we can write it here positive plus D in case of a convex lens. In convex lens, the power is positive. Since why the power is positive is because the focal length is positive in case of a convex lens. So therefore the power will become positive. So when the power will become positive, then write it plus D. Okay, then in a concave lens, the power is negative, minus D in case of concave lens. Because in a concave lens, the focal length is negative, so therefore the power will also become negative. Okay, so this is about the power of